People look at ancient buildings and assume they're fragile, like one bad shake and the whole thing should have turned to dust. But then you see Hagia Sophia, still standing after nearly 15 centuries in one of the most earthquake-active regions on Earth, and your brain immediately asks, how is that even possible? No steel frame, no computers, no modern seismic codes, just stone, brick, and human intuition. This isn't luck, and it's definitely not a miracle. This is one of the smartest engineering stories history ever forgot to brag about. To really understand how this dome survives earthquakes, you have to zoom out and look at the environment it was built in. Hagia Sophia was commissioned in the 6th century by Justinian I, ruler of the Byzantine Empire, in what was then Constantinople. This region has always been seismically active, meaning earthquakes weren't rare disasters. They were recurring events people lived with. Builders didn't have the luxury of pretending the ground was stable. From the very beginning, the structure had to expect movement. Here's where the story immediately separates Hagia Sophia from most ancient buildings. The dome does not sit on thick, solid walls like Roman temples or fortresses. Instead, it appears to float. The weight of the dome is transferred through 4 massive arches using curved triangular structures called pendentives. These redirect force outward instead of downward, meaning when the ground shakes, the energy spreads through the building rather than snapping it apart. This single design choice changed everything. And this is important to understand. Earthquakes don't destroy buildings because they're old. They destroy buildings because they're rigid. A rigid structure resists movement until it suddenly fails. Hagia Sophia does the opposite. It flexes. It moves just enough to release stress without collapsing. That idea sounds modern, but it was baked into the structure 1,500 years ago. Quick pause here. If this kind of weight, how did they know that? History is your thing. Make sure you subscribe to History of Questions. We break down the moments where humans clearly knew more than we give them credit for. The people behind this design weren't traditional builders swinging hammers. They were thinkers. Isidore of Miletus and Anthemius of Tralles approached architecture like a mathematical problem. They thought in geometry, angles, curves, and balance. Instead of asking how to make the strongest wall, they asked how forces travel through space. That shift in thinking is why the dome behaves less like a block of stone and more like a living system. Another massive reason the dome survives earthquakes is weight, or more accurately, the lack of it. The bricks used in the dome are unusually light, much lighter than typical Roman construction materials. Less weight means less inertia during shaking, which directly reduces destructive force. On top of that, the mortar used is lime-based and flexible, allowing microscopic movement instead of brittle failure. Modern testing shows this mortar can even self-heal tiny cracks over time. But here's something people don't like to hear. The original dome didn't survive. In 558 CE, an earthquake caused a partial collapse. And this is where the real genius shows up. Instead of rebuilding it exactly the same way, the engineers changed the design. They rebuilt the dome higher and steeper, reducing horizontal forces that earthquakes generate. Failure wasn't hidden, it was studied. That redesign dramatically improved how the dome handles seismic energy. A steeper dome pushes forces more vertically, meaning less sideways stress during shaking. This change alone is why the current dome has survived earthquakes that destroyed surrounding buildings centuries later. Hagia Sophia is not just ancient, it's upgraded ancient. If you're enjoying how deep this goes, don't forget to subscribe to History of Questions. We don't just tell stories, we unpack the logic behind them. Over the centuries, Hagia Sophia became something rare, a structure that learned. After each major earthquake, reinforcements were added. Buttresses were built. Weak points were strengthened. Different empires contributed solutions, turning the building into a layered record of seismic engineering across time. Instead of one frozen design, it evolved. Even the placement of windows matters. The ring of windows at the base of the dome reduces weight while allowing light to flood in. Less mass means less force during shaking. and the openings interrupt crack propagation. What looks like pure beauty is structural strategy hiding in plain sight. Modern engineers have run simulations on Hagia Sophia using computer models, and the results are humbling. In some seismic scenarios, the dome performs better than modern concrete buildings that lack flexibility. That's a hard pill to swallow, but it proves something important. Understanding physics beats brute force construction. At its core, Hagia Sophia survives because it doesn't fight earthquakes. It negotiates with them. It bends, redistributes stress, absorbs shock, and recovers. Ancient engineers didn't try to dominate nature. They worked with it. That mindset might be the most quake-resistant innovation of all. If this explanation just rewired how you think about ancient engineering, that's exactly why this channel exists. Subscribe to History of Questions, like the video, and share it with someone who thinks old means outdated. Because sometimes the smartest answers are hiding right under our feet.